are back. So I hope you guys have done the work and graphed the functions. I have done it here, so let me explain. I hope you guys got the same function as me. So this is the red one is the final answer in the first case. So this is the function we were talking about. There were two examples left from 3.6, remember? So this is one of them. So f of x is negative of 1 over 3 raised to 1 minus x. So I took the 1 over 3 to the x as the base function, although we see a negative sign with the x. But I just want to simplify this and show you what this can be changed to. So we have 1 over 3 raised to 1. So notice here 1 over 3 can be written as 3 raised to negative 1. And then we have the power 1 minus x. Now the negative 1 power and then the power 1 minus x, they get multiplied. So we get negative of 3 raised to negative 1 plus x or x minus 1. So if you notice here, this is now e to the x function. So we can take this as our base and then go do the problem, or I went like a step backward and I took 1 over 3 to the x as my base function. Now when you have this situation, when you have a negative with the x sign, you have to be careful about the transformation. So remember we have that if you have f of x plus h, then it means shift left h units. But if we have f of x minus h, then we have shift right h units. But if you have f of negative x plus h, remember what you have to do is, because what we have learned, or what the rule is, when something is added in h or something is subtracted from h, not from something added in x or something subtracted from x, not in negative x. So whenever you have negative x, the best way to do it is take the negative, factor out the negative, and then simplify. For example, we could also have done it this way. Actually, I did it that way. If you have, like, we have 1 over 3 raised to the power of, we have 1 over 3 raised to the power of negative x plus 1. Okay, so you can now say 1 over 3 raised to the power of negative times x minus 1. So now this negative you can apply on 1 over 3 and you get 3 to the x minus 1. So same thing as I did before. But if we keep it like, if we keep it like this, then if you can do either, because there is a shift right 1 unit and then there is a flip over the y-axis, the negative sign in front of x minus 1. So you can do either of them first, but be careful when you are doing the shifts. So here, this is what I did. First I took the base function and the 3 points related to it. Then I went to this step. I did negative x, 1 over 3 to the negative x. So this is reflected over the y-axis or flipped over the y-axis. So my points changed, the x values, because there was the x value and the y value remained the same, but they kind of shifted, right? So it flipped. So negative 1 it was 3 here. Over there it became 1 over 3. And where it was 1 over 3, it became 3. And then I did negative x plus 1. So what did this do? this gave me a shift right. Why right? Because remember, this is being added to x, negative x, not x. If it was x plus 1, then it would have been shift left. But because it is negative x plus 1, so if you will take the negative out inside, you will get x minus 1. That's why it's shift right 1 unit. So accordingly, the values changed, the x values, and then the last thing was to flip it over the x-axis. So this is what I got, and I have the intermediate steps as well drawn, the functions. So this was original one, 1 over 3 raised to the so this is 1 over 3 raised to the x, and this is the flip over the y-axis. This is the shift over the 1 unit to the right, and then flip over the x-axis last, the final result. So note here, as I said earlier, showed you, so we could write it like this, which goes like that. Okay, so we could reflect over the, I did this, I took this as my base function, then I reflected over the y-axis, and then now the second and the third step, like this shift and the flip and the shift, you can interchange them. Also, we could have taken 1 over 3, just 3 to the x as our basic function, then it would have been less transformation. So in the next example, this is what I did. Okay, here I wanted to tell you something. The common mistake that I have noted that students do, when you have a negative at the x, be careful. You have to figure out the negative, as I said earlier, because what students do, they think that negative x means flip over the y-axis, and then because it is plus h, so they think it's a shift left. It's not shift left because this x is being added to negative x. So it means from x it is being subtracted. Okay, now we look at the next example, last one. Okay, this is e to the negative x minus 1 plus 3. So now I took e to the negative x as my base function, and then that would mean now I can factor out the negative sign, so it gives me x plus 1. So it means shift left 1 unit. So that gave me the point wise, I got this one here, and then the next was just the shift up 3 units. So I got final this answer, and there is my graph. So I remember to shift the horizontal asymptote. So now if I want to write the domain is going to be negative infinity to infinity. Range will be 3 to infinity. And HA will be y is equal to 3. And what else? The last thing is y-intercept. Y-intercept will be y equals, so you may notice here it will be 1 over e plus 3. Okay. What I have here. Is it going to be? Yep. So 3 plus 1 over e. And 1 over e, remember we said it 0.4, so we get something about 3.4. So that is the y-intercept, and there is no x-intercept in this case. Okay, so this is how we graph these functions. I hope now you guys understand.